Okay, hi grade 12s. Today we are going to explore the relationship between two sets. So, suppose we wanted to look at seasons that students at FCI prefer. To simplify things, we're going to ask whether they like winter or summer and allow them to choose one of the two seasons, both seasons, or neither season, because there's always a person like that. Okay? So we survey 100 students and find out 48 like winter, 56 like summer, and 10 of them don't like either. We can summarize the findings of this in a Venn diagram. So here's what we know for sure. We know that 10 of them don't like either. So there's 10 people floating around the outside. Ooh, actually, I guess I don't have to put that. I wasn't looking very carefully. There is already a 10 there. But it says 48 like winter and 56 like summer. How do we do that? Well, there's going to be some people that like both winter and summer. So really, how do we find out what goes on each of those spots in the Venn diagram? Has anybody seen a Venn diagram before? Okay, good. Venn diagrams are a staple on your provincial exam in June. Again, I can say that confidently because I've been on a team of teachers for 8 years that have developed this exam. And here's what I can tell you. If you make a Venn diagram, put a box around it. If you don't put a box around it, you lose a communication error. So always put a box around your Venn diagrams and label everything in the Venn diagram. There's 2 circles in this Venn diagram. It's kind of created almost for you. And each of the circles is labeled. One has a W beside it and one has an S beside it. It's pretty straightforward that the W bubble is going to be the people that like winter, and the S bubble is going to be the people that like summer. And where those 2 bubbles intersect in the middle, that's people that like both winter and summer. And what we have to do is we have to figure out how many people go in each of these 3 spots in the Venn diagram. So again, how do we do that? Well, I guess you could do it by guess or check, but that seems pretty ugly. Here's what I know for sure. We could say that there's X people here. I don't know what X is, but there's X people there. And if there's X people there, then there's going to be 48 minus X people out here. Because, like, say there's 8 people here, there'd be 40 of them over here. Because in the W circle, there's a total of 48. And likewise, in the S circle, there's a total of 56. So therefore, this is going to be 56 minus X. Now, here's what I also know. I know that the number of people in those 3 parts of the Venn diagram is going to add up to what? It would be 100, except that there's 10 people already outside that don't like either, so it's going to add up to 90. So in other words, what we're going to do here is we're going to say that this, and this adds up to 90, and we're going to solve for X. So let's do that. 48 minus X plus X plus 56 minus X is equal to 90. So, now, what do we get? 48 plus 56? Well, that's 104. Minus X plus X, well, they cross each other out, don't they? And we're just left with minus X. So now what we have to ask ourselves is, 104 minus what is equal to 90?
My brain just crashed.
The answer is 14. So X is 14. So that means that 14 goes here. And if 48 like Winter, then it's going to be 48 minus 14, which is 34, goes here. And 56, take away 14,
42.
is going to be 42 that goes here. This is a fairly straightforward Venn diagram. It's a two-circle Venn diagram. A two-circle Venn diagram is as easy as this gets. We will take a look later on at three-circle Venn diagrams and how they work. In this Venn diagram, there's 4 possibilities. Somebody likes both seasons. Somebody likes winter only. Somebody likes summer only. And somebody's a grump and doesn't like either of them. Okay? There's 4 possibilities. There's 4 groups of people. Okay? And when we make a Venn diagram, it has to be labeled. Like I said, we have W and S there to represent the people that like winter and the people that like summer. We have numbers in each of the 3 spots in the Venn diagram, as well as outside the circles to represent people that don't like any of those options. Okay? And there's a nice little box that goes around the Venn diagram. All those things are needed when we're talking about Venn diagrams. Okay? All right. Example. Consider the following sets. The universal set is defined as natural numbers up to 20. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Those are universal numbers. P are the prime numbers up to 20. And H has no special classification, but it's the list of numbers 4, 6, 7, 11, 14, 16, 18, and 19. Part A asks us to draw a Venn diagram showing these sets. Okay? And then in part B, we're going to say how many are in each of those different categories. Okay? Alright, so what do I want to do? I think I just want to make a box. The first thing I want to do is I want to make a nice little box here. Here's my box. Okay. We want to go ahead and we want to draw 2 oval-like thingers. There's 1. There's 2. There should be a spot where these things overlap. Yep. We should label them as P and H. There's P. There's H. Now we should go ahead and place the numbers in the appropriate spot. So basically what I would do is I would think of this as, go through each of the numbers. Okay? 1. Is it prime? Nope. Is it an H? Nope. So 1's floating out here. There's 1. Okay? How about the number 2? The number 2 is prime, and it's not an H, so it'd be in here. Let's go to 3. Is 3 prime? You betcha. But it's not an H. 4, is it prime? No. Is it an H? Yes. So it's right there. 5, is it prime? Yep. Is it an H? No. 6, prime? No, but it's an H. 7, prime? Yep. Is it an H? Yes. So it's in the intersection. 8, prime? No. Is it an H? No. So it's out here somewhere. 9, prime? No. Is it an H? No. So it's out here. 10, prime? No. Is it an H? No. So it's out here. 11, prime? Yes. H, prime? Is it an H? Yes. So we got 11 in both. 12 isn't prime and it's not an H. So it's floating outside. 13 is prime, but it's not an H. So it's in here. 14 is not prime, but it is an H, so it's in here. 15 isn't prime, and it's not an H, so it's out here. 16 is not prime, but it is an H, so it's in here. 17 is prime, but it's not an H, so it's right here. 18 is not prime, but it is an H, so it's here. And 19 is in both, so it's right here. And 20 is not neither, so it's out here. Now I just want to clarify what we've drawn here. I want to make a second diagram, and you'll see why I make the second diagram in a second here. This diagram is a Venn diagram, but this Venn diagram is different than the last Venn diagram. The last Venn diagram we saw had a summary of how many elements were in each part of the diagram, whereas the diagram I just drew you tells you every single element and where they live. So you might want to draw something similar to this that just summarizes what we have here. So here's another rectangle. Here's an oval. Here's another oval. Here's P, and here's H. So here's what I mean by that. There's 1, 2, 3 things that intersect. So I'm just putting the number 3 to say that there's 3 things. There's 5 things that are in H, but not in P. And there's also 5 things in P that are not in H. And there's 7 numbers floating out all by themselves that aren't in P or in H. So just to clarify, the first diagram that we drew shows where every single number lives. The second diagram is just a summary of how many numbers go in each of those spots. And the second diagram is going to be probably a little bit more helpful when we go to answer all those questions. Okay? Now, let's take a look at what these questions ask. I think they get a little tougher as we go, but how many are in set H? How many numbers are in set H?
5. 8.
Well?
8.
8. Set H is anywhere in that circle of H. It's 8. Right? Now, I know somebody said 5, and that's the answer to 2. Okay? So, 2 says what's in set H, but not in set P. That's 5. Can we see the difference between 8 and 5? 8 is the entire oval in H. That's all the numbers in H. But 5 is the number of numbers that are in H, and only H. Okay? Make sense?
Yeah.
Okay. How many are in set P? 8. Yeah. And how many are in P but not in H? 5. Yeah. How many are in set... Okay, this is where it gets a little tricky here. How many are in set P or H? P or H?
8. 16.
13. Because we're looking for anything in here. Anything in here. It's 13. Okay? How many of them are in P and H? 3. That's correct. Okay, there must be a typo here, because I'm going to do this. Not in P. How many are not in P?
7.
No, not in P.
15. Or 13, 12.
12. Okay, because P is this. How many aren't in P? That's those. So it's 12. Now, just so we're clear, If we're talking about not in P, we would say that by saying P prime or P bar. And there are some other ways that we say that, but those are probably the two most common ones. P prime or P bar, they represent the stuff that's not in P. Okay?
To P or not to P? Just kidding.
That is the question. So that's all she wrote. Okay? So the idea of what's in here and here, it's a little different with Venn diagrams. The cool thing about Venn diagrams is it's visual. So you can see it, but you just have to be clear what's being asked so that you can answer what you're supposed to. So, like I said, today is exciting. It's textbook day. There's the homework. It's numbers 1 to 5 on pages 160 to 161. And we're going to say this is worth marks. So, let's get to it.